और संरचनाओं को बढ़ावा का कार्य शुरू किया है। प्राकृतिक आपदा के दौरान इंफ्रा डैमेज एक ऐसा विषय है जिस पर किसी का उतना ध्यान नहीं गया जितना होना चाहिए। विकासशील देश इससे विशेष रूप से, इसलिए यह संगठन एक महत्वपूर्ण पहल है और माननीय प्रधानमंत्री जी इस विषय को लेकर हमेशा कार्यक्रम को बढ़ावा देने और योजनाओं के प्रति जागरूकता रखने पर विशेष ध्यान देते हैं। माननीय प्रधानमंत्री जी की प्रेरणा से सरकार आपदाओं से होने वाले नुकसान को कम करने के लिए निरंतर प्रयासरत है और इसके परिणाम भी सामने आए हैं और इस परिणाम को लाने में सरकार की जितनी भी संस्थाएं हैं, एजेंसियां हैं, उसका बहुत ही योगदान रहा है। माननीय गृह मंत्री जी आपदा प्रबंधन को लेकर हमेशा संवेदनशील तथा तत्पर रहते हैं। हमें माननीय प्रधानमंत्री जी के आपदा जोखिम न्यूनीकरण के लिए 10 सूत्री एजेंडे पर काम करने और उसको आगे बढ़ाने के लिए लगातार प्रयास जारी रखने होंगे। जलवायु परिवर्तन संगठनों, जलवायु परिवर्तन, प्रदूषण, महामारी आदि की घटनाओं को भू राजनीतिक सीमाओं से अलग करके देखा जाना चाहिए। इसके लिए देश हित में संयुक्त राष्ट्र एजेंसियों और उसके सहयोगी देशों, संगठनों और सहयोगियों को इस उद्देश्य से सुदृढ़ किया जाना चाहिए। आपदा संबंधी सभी सूचनाओं का प्रसार, पूर्वानुमान, प्रारंभिक चेतावनी इत्यादि को संयुक्त राष्ट्र संघ की एजेंसियों के हर संभव सहयोग के माध्यम से निर्बाध बनाना जाना चाहिए। भूकंप, गर्जना, ओलावृष्टि, जलवायु संबंधी विसंगतियों इत्यादि के संबंध में विश्व में उपलब्ध सर्वाधिक आधुनिक संचार और प्रौद्योगिकी देश में सुगमता से उपलब्ध करवाई जानी चाहिए। कई राष्ट्रीय और अंतर्राष्ट्रीय एजेंसियां जो अनेक अन्य व्यावसायिक क्षेत्रों में प्रशिक्षण प्रदान कर रही है, उनकी सहभागिता को स्वीकार करते हुए औपचारिक बनाया जाना चाहिए तथा उसे देश के आपदा प्रबंधन ढांचे में समाहित किया जाना चाहिए। देश के पूर्वी और पश्चिमी तटीय क्षेत्रों को 7 चक्रवात चेतावनी केंद्र संभालते हैं तथा भारत मौसम विज्ञान विभाग ने चक्रवातों के संबंध में पूर्व सूचना प्रदान करने की पूर्ण त्रुटि विहीन क्षमता का प्रदर्शन किया है तथा विश्व स्तर पर, राष्ट्रीय स्तर पर प्रशंसा अर्जित की है। विश्व में चक्रवात समुत्थानशील और संरचनाओं के साथ आगे बढ़ते हुए हम विश्वास से कह सकते हैं कि इस दिशा में पूर्व की अपेक्षा एक महत्वपूर्ण परिवर्तन आया है और 1999 के ओडिशा सुपर साइक्लोन, जिसकी चर्चा पूर्व के कई वक्ताओं के द्वारा हुई है, से अभी तक जीवन क्षति की दर को काफी कम किया गया है। यूं कहें कि अब 2 अंकों में घटकर रह गई है, जो पहले के तुलना में काफी कम है। कम जान माल का नुकसान उठाना पड़ता है। गैर संरचनात्मक उपायों पर देश की हिस्सेदारी के संदर्भ में बनाई जाने वाली नीतियां, विनियमों और योजनाओं जो कि बेहतर तटीय प्रबंधन को बढ़ावा देती है, आप इस बात को स्वीकार करेंगे कि हमने इस विषय की शिक्षा तथा पहुंच स्थापित करने के अभियानों द्वारा इस दिशा में एक अभूतपूर्व प्रगति की है और यह देश के लिए गौरव की बात है। भारत सरकार ने चक्रवात आश्रयों का निर्माण, चक्रवात प्रतिरोधी भवनों का निर्माण, सड़क संपर्क, पुलिया, पुल, नहरें, गलियां, लवणीय तटबंध, सतही पानी के टैंक, संचार और बिजली पारेषण नेटवर्क आदि जैसे विभिन्न संरचनात्मक उपायों को अपनाया है। भारत सरकार ने देश में चक्रवात जोखिमों के समाधान के लिए राष्ट्रीय चक्रवात जोखिम शमन परियोजना की शुरुआत की है। विश्व बैंक के माध्यम से वित्त पोषण राष्ट्रीय चक्रवात जोखिम शमन परियोजनाओं के दूसरे चरण का उद्देश्य ये था कि 13 परियोजनाएं राज्यों के तटीय समुदायों में चक्रवात और अन्य जल मौसम संबंधी खतरों को कम किया जा सके तथा राज्य की संस्थाओं की क्षमता बढ़ाई जाए ताकि आपदा प्रक्रियाओं के लिए प्रभावशाली तरीकों से योजना तैयार की जा सके। भारत ने समुदायों में पूर्व चेतावनी के प्रसार में मौजूदा त्रुटियों के समाधान द्वारा तटीय क्षेत्रों में भेद्यता को कम करने के लिए चक्रवात पूर्व चेतावनी प्रसार प्रणाली में महत्वपूर्ण प्रगति की है। भारत ने महत्वपूर्ण बुनियादी ढांचे में निवेश, उसकी क्षमता में सुधार तथा आपातकालीन आश्रय स्थलों पर पहुंच, निकासी के लिए मार्ग, चक्रवात से महत्वपूर्ण अवसंरचनाओं की रक्षा तथा मौसम जल संबंधी जोखिम से रक्षा के माध्यम से तटीय समुदाय के लिए चक्रवात समुत्थानशील बुनियादी ढांचों के निर्माण में भी प्रगति की है ताकि संभावित क्षति को कम किया जा सके तथा निर्विघ्न सेवाएं सुनिश्चित किया जा सके। अस्थायी तटीय अवसंरचना के सृजन के लिए नहरों का निर्माण, नवीनीकरण तथा बेहतर जल निकासी के लिए तटबंधों का निर्माण, शेल्टर बेल्ट रोपण, बह गए सड़क संपर्कों का निर्माण, संस्थागत क्षमता निर्माण तथा जोखिम न्यूनीकरण अध्ययन और महत्वपूर्ण संरचनाओं, सड़क पुलिया पुल का निर्माण, नव निर्माण महत्वपूर्ण कारक है। मैं विभिन्न योजनाओं और डिजाइन के दौरान उपयुक्त निवारक उपायों में से कुछ पर कार्य आरंभ करने के लिए एक सही मंच को प्रोत्साहन देने का भी आप सबों से आग्रह करता हूं, जो कि पर्यावरणीय रूप से और सामाजिक रूप से वर्तमान आधारभूत अपेक्षा अधिक अस्थायी होंगे तथा देश के तटीय क्षेत्रों में उद्योगों की भेद्यता को कम करने या समाप्त करने में सहायक होंगे। आज के इस 3 दिवसीय संगोष्ठी में जो विषय है उद्योगों का और संरचनाओं का और समाज के समुत्थानशीलता का, मैं समझता हूं कि पहले भी चर्चा आप सबों के द्वारा आई है कि टीम इंडिया की तरह हमको काम करना पड़ेगा और सबको एक संकल्प के साथ काम करना पड़ेगा। माननीय प्रधानमंत्री जी ने डिजास्टर मैनेजमेंट का, आपदा प्रबंधन का दृष्टिकोण हम सबों तक पहुंचाया है और इसमें संवेदनशीलता की जरूरत है। लेकिन जब हम टीम इंडिया के रूप में काम करेंगे, यह भी सही है कि आपदा को आना ही, बारिश होगी, बाढ़ आएगा, भूकंप होंगे, तूफान आएंगे, कभी कम, कभी ज्यादा, कभी बहुत ज्यादा, और हर प्रकार से नुकसान इस देश को पहुंचता रहा है और दुनिया को पहुंचती रही। इसका अंदाजा विश्व भर के देशों को है। तो इसमें आपसी संबंध और समन्वय और एक दूसरे को सहयोग की प्रवृत्ति के साथ हम सबों को काम करना पड़ेगा, जिसका आग्रह माननीय प्रधानमंत्री जी बार बार करते हैं और इसकी चिंता भी करते हैं। आपदा प्रबंधन में कई तथ्यों की जरूरत होती है, जैसे हम समाज के बीच जागरण का काम करते हैं। पीएमडी सूचना भी देती है पहले कि तूफान आने वाले हैं, बाढ़ होगी, बारिश की अत्यधिक संभावना है, तूफान आएगा। अब तो गर्जना के विषय में भी मौसम विभाग द्वारा जानकारियां दी जाती है और यह इस जानकारियों पर एक अच्छी व्यवस्था सरकार ने, केंद्र सरकार ने की है, जो जिसके सब हम सभी पार्ट हैं कि हम सब मिलकर उस पर चिंता करते हैं और अनुमान के आधार पर जो आकलन आता है उसके लिए हम सब योजना बनाते हैं, लेकिन उसको और ज्यादा मजबूत करने की जरूरत है। मजबूत करने का मतलब यह है कि आज जो जोखिम हमारे सामने आता है आपदाओं का, चाहे जो अनुमान है, तो उसके लिए जिन जिन चीजों की जरूरत है, जैसे आज उद्योग विषय भी अपने पास है कि आज जो फिक्की के द्वारा यह कार्यक्रम किया जा रहा है, तो उद्योग एक ऐसा विषय है कि ठीक है, जब आपदा में मानव ताकत तो लगती ही है, मानव बल तो लगता ही है, उसमें बुद्धि भी लगती है, लेकिन सबके साथ साथ संस्थाओं का, समाज का सहयोग भी मिलता है और उसके बिना काम भी नहीं चलेगा। लेकिन हमको उस आपदा से निपटने के लिए जिन जिन चीजों की जरूरत होगी वह उद्योग के उत्पादन से ही हमें प्राप्त होगा। उद्योग इकाइयों से ही मिलेगा। हमको बड़े बड़े यंत्र की जरूरत पड़ती है, बड़े बड़े रासायनिक तत्व की जरूरत पड़ती है, केमिकल की जरूरत पड़ती है, कई ऐसे यंत्र की जरूरत पड़ती है जो तूफान के बाद भी हम मानव जीवन को स्मूथ कर सके, सामान कर सके, इंफ्रास्ट्रक्चर को हम जल्द निर्माण कर सके। इसके लिए भी उद्योग इकाई द्वारा उत्पादित सामग्रियों को उत्पादन की जरूरत होती है। तो मैं समझता हूं कि इस पर भी हमको विचार करना चाहिए कि जो पूर्व के जो हमारे आकलन है और आपदाओं से जो अनुभव हम लोगों ने प्राप्त किया है, उसके आधार पर किन किन चीजों की जरूरत है, चाहे वह अवसंरचना की हो, चाहे वह उद्योगों के उत्पादन से यंत्रों की हो, मशीनों की हो, या रसायन की हो, किसी भी प्रकार की हो, हमको उत्पादन से लेकर समन्वय से लेकर हमको एक भाव के साथ काम करने की जरूरत है, जिस ओर 6 वर्षों में भारत ने माननीय प्रधानमंत्री जी की प्रेरणा में काफी आगे बढ़ा है। इसको और निरंतर आगे बढ़ाने की जरूरत है, और जिस प्रकार से सब मिलकर मेहनत कर रहे हैं, प्रयत्न कर रहे हैं, प्रधानमंत्री जी से जो मार्गदर्शन प्राप्त हो रहा है और गृह मंत्री जी का जो योजना है, उसके अनुरूप हम सब आगे बढ़ेंगे, यह विश्वास है। को तत्परता से काम करने की जरूरत है, और सेवा भाव तथा यह देश हमारा है, इसका नुकसान हमारा है, या इसका नुकसान हमारी संस्था का है, हम सबका है। इस उद्देश्य से हम काम करेंगे और हम एक अच्छी सेवा दे सकेंगे, और आपदाओं के प्रबंधन से हम नुकसान को बहुत ज्यादा कम कर सकेंगे, और इसकी सफलता की ओर हम सब बढ़ भी रहे हैं। आगे भी सफलता आप सबों के समक्ष हो, इसी शुभकामनाओं के साथ बहुत बहुत धन्यवाद। जय हिंद। पुनः एक बार फिक्की को ये 3 दिवसीय संगोष्ठी आयोजन के लिए हम आभार व्यक्त करते हैं, धन्यवाद देते हैं, और यह फलदायी होगा, इसकी शुभकामना भी करते हैं।
माननीय मंत्री जी, बहुत 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 धन्यवाद हमें प्रेरित करने के लिए। एक बहुत ही भविष्यदर्शी और मैं कहूँगा प्रेरणादायक आपका भाषण इनॉग्रेट करने के लिए, इस उद्घाटन करने के लिए इस संगोष्ठी का बहुत बहुत धन्यवाद। आपका समय निकालने के लिए बहुत बहुत शुक्रिया। जितने भी पार्टिसिपेंट, उन सब की तरफ से, जितने भी पार्टनर्स हैं, जिसमें फिक्की, NIDM, National Disaster Management Authority, Economic Advisory Council to the Prime Minister, डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी, और ढेर सारे मौसम विभाग और NRSC, NDRF, इन सब की ओर से मैं आपका बहुत बहुत तहे दिल से धन्यवाद करना चाहता हूं। और आपने जो हमारे को कुछ चीजें बताई हैं जो हमें समझनी है, हम उस पर आपका मार्गदर्शन फॉलो करेंगे और उसी पे चलेंगे। बहुत बहुत धन्यवाद। Over to, I would like to request Lieutenant General Dr. J.R. Bhardwaj, for your vote of thanks and concluding remarks. Introduction of General Bhardwaj, although he needs no introduction. Formerly Honorary Surgeon to the President of India, was appointed as the member, one of the founder members of National Disaster Management Authority, an appointment accorded status of Minister of State in the Government of India under the chairmanship of Honorable Prime Minister of India. Prior to the appointment, he served as the DG AFMS in the rank of Lieutenant General in Indian Armed Forces. Over to you, General Bhardwaj, for your concluding remarks and vote of thanks. General Bhardwaj.
Thank you. It's been a pleasure today deliberations, and I want to say a couple of things before I extend my hearty thanks to all participants today. First of all, I would say natural disaster will occur. The answer is that we must prepare, and we must introduce resilience all around. It is infrastructure, it is response, or whether it is most important part is the preparedness of the community. I have no hesitation in telling that since the super cyclone of 1999, state of Odisha took a forward lead and has established itself as a leader in management of cyclones. Since then, they were the first one to have the state disaster management, along with the preparedness, having shelters, on higher grounds and preparing the community for this. The deaths that occurred in 1999 has been reduced to almost that today. Uh, uh, all other agencies concerned of the state and the state settlement have their best. This is one natural disaster management. There's a lot of progress occurred for managing this disaster, directly as well as through the national disaster, micro disaster program that was funded by WHO, Government of India, which we started when I was the member in the National Management Authority and concluded in 2020 by end May, and Ministry of Home and Home Affairs. Thirdly, so must congratulate FICCI, which now I'm part of it, that in 2010 onwards, 2011 onwards, actually, when we brought out the national guidelines from NDMA, FICCI is the only organization which worked on PD move, and along with the NDMA, NIDM, we have we prepared and to prepare the community, we really cannot proceed further. So today we stand the best, one of the best in the world early warning system. We have one of the best infrastructure. We have one of the best, almost the best NDRF. No other country in the world NDRF of that capability. Trained in all spheres of life, and we are very well prepared as far as this is concerned. Whatever we improvement we do, go on doing it, especially in the preparedness of the country for this. There are lots of things that have been talked today by our colleagues. It's my duty today also to thank the Honorable Minister who has spared his valuable time today to join us, and also Honorable Member from NDMA. And colleagues, I know them personally because I have worked with them from 2005 onwards in disaster management. And most of them have been very actively participating, and it is because of credit and the hard work of people there, like Professor Purti is here, and we have so many other people who have not, though they have been the chairpersons of the various institutions, and but still our hand in disaster management. And Professor Chandan, you call him on the middle of the night and say, so we partner with NDMA. Last but not the least, I must that management, disaster management culture of disaster management only after NDMA was established by the Government of India in 2005. Before that, we never heard that there is a disaster management, something like that, which can occur for any disaster nature. We suffered, and whatever response was possible was given by the government. But today, I would say, starting such a mitigate goes on to bring out rules and regulations as directed. Exemplary work has been done by CIDMBF board, not only in the COVID-19. We did not let people in the preparedness disasters. We conducted many safety issues on chemical industry disaster management. We got on to the natural disaster industry. We got on to the last webinar, and now we are working on cyclone mitigation. Our efforts through our CIDM board from UK, and surely this is going to help each every one of us. We your blessings and your good wishes and your presence in all our endeavors, and I have no other words more than this what has been spoken by Mr. Chinoy, Mr. In thanking all the partners. I once again thank everyone and extend my heartiest thankfulness to all of you for having joined us now. Jai Hind.
Thank you so much, General Bhardwaj, for your ever inspiring and motivating address and presenting vote of thanks to the Honorable Minister and to all the dignitaries who are present amongst us. बहुत-बहुत शुक्रिया आपका और मंत्री जी आपका भी. I would like to, before we conclude the inaugural session, I would like to thank all our partners and our sponsors, including the GIS partner, ISRI India, GAIL India, Indian Oil Corporation, Power Grid, RMSI, and of course, the Economic Advisory Council, the Prime Minister, National Disaster Management Authority, Department of Science and Technology, and most importantly, our very valued partner in National Institute of Disaster Management, Ministry of Affairs. Thank you so much, ladies and gentlemen. We shall shortly start with the first technical session, which would be chaired by none other than the member of the CIDM, FICCI CIDM board, Shri Labendu Mansingh Sahab. The first technical session 1 would be on cycle on establishments and infrastructure assessment and modeling approach with recommendations. And we have very eminent speakers. Mr. Mansingh will be chairing this. Like Professor CVR Murthy ji, thank you so much for joining us, Murthy Sahab. Thank you so much. It's always very inspiring to see you on the screen. Dr. Ahmed, although I welcomed you earlier, Dr. Muzaffar Ahmed for being with us again today. Mansingh Sahab, before I hand over to you, I would just mention on the speakers we have Dr. Chandan Ghosh, Professor and Head of Resilient Infrastructure Division, National Institute of Disaster Reform of Government of India. Then followed by him, we have a presentation by Dr. CVR Murthy, Professor, Indian Institute of Technology, Madras. And then the last speaker of this session is Mr. Sharat Tripathi, who's the CEO of Fluidint, which is a Transsoft Group company. The subject, the title is the Cyclone Impacts on Establishments and Infrastructure. Before we move forward, I would like to briefly introduce Shri L. Mansingh, who is the former Secretary Government of India and former Chair of Petroleum and Natural Gas Regulatory. He belongs to the 1970 batch of IAS of Gujarat cadre. His last assignment prior to superannuation was Secretary to Government of India and Ministry of Consumer Affairs, Food and Public Distribution. Mr. Mansingh was directly responsible for the implementation of new industrial policy in 1991. And we all remember that the turning point of India's economy that very year, which started the process of liberalization. He was then the Joint Secretary Industry Policy in the Department of Industrial Development, in charge of Secretariat for Industrial Approvals. Sri Mansingh was appointed as the first chairperson of Petroleum and Natural Gas Regulatory Board, PNGRB, in June 2007. Before we introduce the speakers, I would just like Mr. Mansingh to make some introductory remarks. Over to you, Mansingh sir.
Thank you, Rubab. We have now, first thing is that the voice, probably the audio part needs to be, some looking after, because its voice of General Bhardwaj was breaking, no voice while speaking was breaking. So there seems to be some problem with the audio part of it that you can attend to. Now, without wasting, the second point is that we are already a little behind time. So the time frame also you should indicate so that that way the speakers, the panelists can adjust their time. I would just like to say because lots of things which by nature of introductory remarks have already been said by the speakers during the inaugural address. Now we have a long coastline, and as it was mentioned, basically the most of the developments in this country have taken place on the coastal belt. So you have dense habitations, by very progressive industrializations, assets in the term of hotels, institutions, etc. Everything is on the coastline, and I would like to just emphasize, without taking too much time, is that one aspect which is resulting in not only the severity of the cyclones is that we have managed to degrade our mangrove forest, which was protecting our coastline. We have not paid as much attention we should have paid to the coastal plantations, particularly the saru plantations, which acts as a shock absorber of the cyclone. So therefore, the severity of the cyclones, whether it is the Odisha super cyclone or Kandla cyclone, which led to a lot of deaths and destruction of assets. It is because we have neglected the environmental aspect of reducing the impact of this thing. I would not take much more time. I will request Rubab to introduce the panelists. Rubab, please take over and indicate the time limit for each speaker, because I don't know how we are going to adjust the. We are already running behind time.
Yes, sir. We are running behind schedule, but I'm sure the eminent speakers in this session would be towards that, and they would try and, if required, their presentation time. Presentation. Ghosh, who's the professor and head Resilient Infrastructure Division, NIDM. Before I go on for his presentation, Professor Chandan Ghosh, who's currently with the Ministry of Home Affairs in NIDM. Professor Ghosh does research capacity building for engineers, architects, planners in disaster resilient constructions, geosynthetics application, disaster mitigation and management, retrofitting, rapid visual screening, disaster documentation, bioengineering solutions by vetiver grass, etc. He did his first PhD from IIT Kanpur, second PhD from Ibaraki University, Japan. His current project is reviving disaster management plan for CPWD establishment. On that note, over to you, Professor Chandan Ghosh, for your presentation.
Thank you for this invitation, as well as our participation together to bring cyclone resilient community, especially for the industry, into one fold and take it further. So today I'm going to speak about the footprints in cyclone resiliency, and with the time frame given, I hope that I'll be able to finish it in 15 minutes. First thing is, we are familiar with what happens to the facilities which in the name of resiliency, they don't have anything. Even though 2004 onward, we have got a very, very enriched world, enriched BIS code and wind code and everything is there. But seeing these things, they don't, that whatever is happening in our cyclone, even though they are of low intensity compared to what happens in Atlantic or even in Japan. But here no resiliency is there, not only inside, also to our airport. Also to our airport, you see major damage to Bhubaneswar airport in Feni cyclone. What is happening inside? So if we take from now onward, or whatever cycles that they are happening, we have a lot of statistics about the economic loss, which I'm going to highlight, about the bringing back to airport like of things to normalcy, and the amount of work is involved day and night, and which our airport authorities, they have been doing, for one example, or even power lines that which get damaged. So where, you know, our power finance corporation, power grid, or who are having, or even in the city where even electricity supply get damaged, especially Hudud in 2014 is the concern, is that one particular example. Of course, the way that they are taking up, I would like to highlight some of the things that what is happening even globally also about the disaster related damage, especially relevant to storm and cyclone. And just to see the footprints that which was there before and after, so where structure remain intact. This we all agree. We civil engineer or structural engineer, we have got, and here it remains intact. What is to be looked into the non-structural part, and how to facilitate wind passing through the airport, but rather closing all the doors and windows is not the way. So we have to go for facilitating this gust wind through the airport, and for that, what kind of modifications to be done, what is the design to be done, rather in the non-structural aspect is the main thing that we have to look into in our coastal airport. This is one aspect. And when we go into just tropical cyclones, they are deadliest, and there are many such reports are coming up, and you can know that since 1900 to this day, and for more than 100 years, even IMD has generated that how many cyclones have come, what are their intensity, all these atlases are there. But when we see the immediate decades, like last decade, if we see, mark the costliest in the modern record of global natural disaster on a nominal and inflation-adjusted basis. These are reports coming up which are getting updated, we are familiar with, they are available online. Just to stress the point that the direct economic damage and losses tallied to 2.98 trillion or 3 trillion during this decade. And this was 1.1 trillion. Think about our annual budget, higher than the previous decadal period, means 2000 to 2009 by 1.88 trillion. So then question comes to us in this forum is that whether our infrastructures are vulnerable to impending hazards. We have or not, and we have no one-line answer. So it needs that to look ourselves that what kind of infrastructure that we are making. And economics of disaster, whether it is scientific or unscientific, and it is difficult to answer, but we have to find out categorical answer, not in reports, but in our action to the infrastructure that we are making or we have made already. Mitigation measures that we have been taking, whether they are economically viable or not, a lot of things to say on this, lot of things to describe on this aspect, but we have not yet taken up these things at the war footing. And any economic feasibility assessment done so far, it is being done, and I will show some reports which are available elsewhere in the foreign organizations, and where we supply this data, and they come in a very nicely that what are the categorical damage and loss that we are facing. Of course, long back, the report was that we lose 2% of our GDP every year, but I will show you many such accounts about the recent report came in. As far as stemming or taking care of heavy rainfall induced slopes or even coastal area which are getting inundated or being eroded away, nature has given us some solution that how it is to be taken care of. It is the grass that which takes care of, or even erosion control in our coastal area or across the country, wherever erosion is there, how locally using our Manrega worker. This is West Bengal example, that how nicely nature has taken care of and using Manrega worker. And so this is what we have to note it, that how many trillions we are losing, but how many trillions we can save by taking care of these local measures which nature has given to us. So now just only coming back to over the last 20 years report, it shows that so many accounts are there through EMDAT, that in total seen in figure 1, which is coming up, we have approximately 1.23 million lives on an average 60,000 per year, and affected a total of 4 billion people. So these are all report generated, and you see that a decade before 1980 to 99 and 2000 to 19, if we see that we are going in a developmental economy with Sendai framework on which is going on, and with a lot of such sustainable development goals that which are in action now till 2030. So when we see that this kind of database, that a decade before and just last decade, how these are increasing. So these are all total deaths, total affected, economic losses in terms of US dollar. Or even if we say human cost of disaster in the last two decades, you can also see that total disaster event type 1980 to 99 versus this, these reports are freely downloadable and managed and procured and available in the internet free, that by these organizations. And also number of disaster reported per country. Here India is also part, because we supply this data, they procure them and put it in this form, and then we can see that how they are. And these are all available. This data is downloadable in a Excel file, and so we can see number of people affected decade before and last decade, that which are all in a much more. So taking sustainable development goals, all the 17 goals there, and we all have noted many reports, research papers are coming out every moment. But the past 4 years have been the warmest on records. So there are many such record-breaking things are happening. Land degradation continues unchecked, and 1 million plant and animal, which we think that we should take care of this thing, plant and animal species are at the risk of extinction. So, and some of the midterm evaluation report, especially goal 9, where build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation, which is relevant to the theme of cyclone resiliency, especially. And then when just last year in 2019, that the report which has brought out that we are too slow. So we have to look at, while all the industries who are participant here, we have to look at this database which are being generated, which are alarming, even though 1 decade is remaining. But this 4 years, 5 years of data is showing that we are still going slow. And at the same time, when again there are some data, especially about the flood, storm, and drought, what a contrast they are. You see, drought and flood and cyclone together, that which is causing that with this increasing trend, that which is taking place here, that it is as we are going towards, it is increasing, and it is increasing trend. And so in order to minimize this damage, and in order to see this, minimize this loss, it is not that how many insurance or reinsurance company are giving insurance to that based on certain models and certain specifications, certain things, but we have to incorporate these things into our developmental perspectives. So And then damage also, you can see that as we are 2000 up to 2016 here, or every year this data is going, and it is going and going and increasing. So whether it is biological, whether it's geophysical, whether it is meteorological, where we are concerned over here. So they are all increasing trend as from 1960s or in the current industry that we have made onward, 1980 onward. So these are all trend, and even we talk which is a technological type, database for 100 plus years shows that, database for 100 plus years shows that we are really must be concerned about that what is happening over the globe or over the region or even locally. Especially today's concern is about our cyclone resilient infrastructures and industries that which are there within 100 kilometer from the coastal area of the country. So again, there are certain things that I want to highlight quickly, that the year that was 2019, since 1851, with an average temperature hovering this degrees Celsius above the 20th century average. So it is almost 1 degree above the 20th century average. There are lots of databases that you can look into. The economic loss due to severe weather events and droughts during these, of course, these are all being catapulted. I have shown you some of these examples there. And 5 of the 10 costliest disasters of 2019 were flood related. Spring and summer flooding in the USA, and separate seasonal monsoon in China and our country, or major flood in Iran. So this you can see, and globally, the insured loss, especially here, there is a special session here. Insured loss is even loss, insured loss, 71 billion. And with Japan hit by 2 devastating typhoon, accounting for 15 billion alone in insurance events. So, but the insured losses from the natural disaster in 2019 were significantly lower than the record 157 in the 2-3 years before. So these are all databases are available, and economic loss to the country, especially in India, due to destructive monsoon, and especially where a cyclone Fani resulted in a cumulative loss of these things. So all these database again that it is subject to the country and the world AON, the global professional firm which brings this database taking from each and every member countries. And of course, there will be a separate session to indicate that how much we are compared to what is happening in other places. Here, our cyclone speed are limited to 200 or 220 kilometers per hour, whereas in this area, Western Pacific, or in this area, Atlantic, they may go even more than 300 kilometers, 350 kilometers, highest it has been recorded. So whatever code and design and infrastructure that we are making, the impact on that or similar infrastructure, we have to look at even higher gust wind that which are experienced elsewhere, but 100 plus years of history, we are seeing that in the last 1 decade or it is all exceeding. And so that way, I wanted to show that this overview of tropical cyclone is shown. Various databases are available. We are still confined to this one, but we have made all these publications available. And then vulnerability atlas also made, which are highlighted. So industry, which are concentrated here, or that area that which are flood prone area, these are already highlighted here. So whenever we are going to make a coastal or coastal belt area, any construction industry, these are the base map that available and generated by BMTPC that we must look into. And so before and after, of course, and all these things that which are going on, we have got lots of things, information minute to minute, 10 minutes, 15 minutes, and even in mobile phone, they are coming and very advanced way. But information wise, we have made a significant step, but bringing industry and industrial facilities and their losses that we have to minimize, taking into this data that which are available. So just only the key points or recommendation. The temperature increase, of course, there are many such things. Increase in frequency of potentially high impact of natural hazards across the world. This could render current national and local strategy for disaster risk reduction and climate change adaptation obsolete in many countries. There are many research reports are coming in the last 1 decade that these are all changing in the last 1 century average that which was predicted in 2007 in IPCC report. These are all getting changed, and in the last 1 decade or so, everything is getting changed and shifting rainfall pattern and other things. And 70% global agriculture, the rain-fed, and 1.3 billion people dependent on degrading natural agricultural land. The considerable impact due to single disaster type in some countries provide an opportunity for more focused disaster risk reduction. Of course, COVID-19 demonstrated a lot. And so I have taken it from CRED report that there is a requirement for strengthening disaster risk governance to manage disaster risk with clear vision, competence, plans, guidelines, funding, which we have seen. Public and private investment, especially in disaster risk prevention and reduction through structural and non-structural, needs to be stepped up to create disaster resilient societies. So these are the things, of course, my next speaker is going to, Professor Murthy is going to highlight, but only thing is that the erection and use of cyclone risk mitigation infrastructure is proving to be an important element in disaster resilience under present circumstances and need to be taken up at war footing. Thank you.
Thank you so much, Dr. Chandan Ghosh, for your very detailed presentation. I think you've touched upon some very important points which you have done, which has a lot, years of experience into that. And we continue to learn from you. And I think we would, on this very subject of cyclone resilience and resilient infrastructure, I think this is just the beginning of us working more closely. And we commit fully from FICCI's side, from industry side, from the private sector side, to be of use, to be of a position to contribute to the cause. Thank you so much. Moving on quickly, I would like to welcome, before I call, I would like to welcome our eminent speakers, and also to begin with Shri Kamal Kishorji, who is the Honorable Member of National Disaster Management Authority. He would be chairing our next session. Thank you so much, Kamalji, for joining us. Welcome Animesh from UNDR, Ardito from UNESCO, and Devajit Das from Igenedo. Welcome to all of you. Next speaker now, I would request Dr. CVR Murthy, Professor IIT Madras. Again, a very renowned personality in the area of structural engineering in the country, not only in the country, but in the region and global as well. Doctor of Philosophy, Civil Engineering from California Institute of Technology, US. A Master of Technology in Civil Engineering, 1986 from IIT Madras itself. And BTech from IIT as well. He's a visiting professor of Department of Civil Engineering in IIT Hyderabad. Department of Civil Engineering, IIT Kanpur. He was professor from 2003 to 2010. Department of Civil Engineering, IIT Madras in 1986 and 87 as well. So he's come back to this very coveted and very renowned institute, IIT Madras. Over to you, Dr. CVR Murthy. I'm looking forward to your presentation, sir.
Thank you, Rubab. Good afternoon, ladies and gentlemen. My pointed agenda this afternoon is to raise some issues that are related to building cyclone resistance in structures of the Indian industries, especially along the coastline. I'm keen on looking at the design of new structures as well as retrofit of existing structures. So quickly, some basics, and then effects of wind and effects of water on structures. Industrial structures come in all sizes and shapes, and they are not structures but subsystems. These subsystems are connected together to make one industry. Each of them in its own has its own peculiarities and specialities, and we require to reflect that in the design. What we generally notice is that the industrial structures are very massive and very stiff, and they're also, some of them are very light and very slender. But what is most crucial is too many assumptions are made in design engineering. And finally, there are huge number of connections whose efficacy is what is under question at this point of time. Also, when you look at the spectrum of all the structures built in the country, I would say Indian industry will stand at number 3 after nuclear power plants and dams. And so that is a level of dignity or respect that we attribute to the structures of the Indian industry, because just now the Honorable Minister has said that keeping the employment intact, even when disasters, even when hazards are realized into events, is the key challenge that we have. So some basics on cyclone resistant design. First off, we know the cyclone occurrence map of India, and we're looking at speeds of 170 kilometers per hour stated on the east coast especially. What is important is to recognize that the peak wind speeds are up to 250 and 300 kilometers per hour, but what is used in design is on a 3-second average, what are the issues. So we are looking at cyclones causing both wind effects as well as water effects on structures. Wind is to be looked at very carefully. Depending on the geometry of the structure, the wind forces will change. And so that requires very special attention. And water, of course, traditional treatments are being used liberally. But what is most important from water point of view is to keep away from it, or keep the water away from the structures in water. So the strategies to mitigate the effects of wind are the ones that I'll share a little bit here. The wind speeds considered in the design process are 200 kilometers per hour. These are the 3-second average values that we use. But the gusts that are experienced are much larger than that, more than 200. So what it calls for is that it is time for us to relook at the wind zone map of India and also the wind speed values. Especially with the occurrence of large number of events in 99 onwards, we need to re-examine the subject with great care. And so the first agenda item for industries to push for is to look for an improved seismic wind zone map of India. These wind zone maps are typically prepared by the Bureau of Indian Standards, so the industry should actually push for the BIS to seek a revision in the wind map of India. Second is the Earth's surface affects the speed of wind, and especially green cover. And so we have to bring that into our planning strategy, and we'll reflect on that again. An additional factor of 1.3 is provided whenever structures are required in the post-cyclone environment. So that is the first way that we are trying to address by increasing the design force in structures. Also, there's another importance factor of about 8% increase in force attributed for structures on the coastline. So in all, about 35% increase is what we're looking at. But what cannot be coded in the Indian standards is the peculiarity of the wind flow around different structures of sizes and shapes that I showed you just now. Each of them has its own special geometry. What happens is when wind blows on the structure, there is a impact that is created on the backside of that structure, and that is the wake of the structure, which actually is responsible for the heavy forces that the structure is subjected to. Also, what you notice sometimes is the structures that are adjoining these in the shadow of the building will experience a very strange behavior, and that is where the design of smaller structures adjoining the big structures is of major importance. And so the big brother has a great influence on the design of the younger, smaller structures. And interestingly, all of this cannot be put into the design code. So what we require is competent engineers who can capture this without having to be told that there is a problem. And what we also notice is industrial structures can be so flimsy and flexible that even a small error, either in the design or in the construction, can lead to catastrophic collapses. And we have seen a large number of that in the Indian industry. So experience over time showed that you cannot stack up these structures one behind the other so closely, and that you need to separate them away. So what it brings us to is the need for a master planning of the industrial campuses from two standpoints. One is structural safety standpoint, which I talked about. Wind, when it blows on one structure, affects the adjoining structure. That is one issue. Also, the impact of damage of one or collapse of one should not really affect the other. And so structural safety is one. And then disaster management point of view, we need to see how to isolate these incidents without affecting others. The most effective way and practical way of trying to mitigate the effects of wind on structures is by using tree cover and tree cover on the foreground. And it is understood that if the height is h, up to 3h, there has been a great relief in the wind pressures that are generated. And so, but sometimes when you plant these trees with gaps between them, that can be again a troublesome spot. So we have to be very careful when we plant these trees. We need to provide these gaps sometimes essentially, but we have to be careful that these are used only for certain specific applications, and that too with the knowledge. And so the intensities can drop up to about 30% to 60%, depending on the level of tree cover that we have used. So once again, a master planning issue on the direction of the cyclonic wind from which it is coming and where the trees should be placed, in what orientation, what dimension, what size and shape. Having said that, even the structures themselves actually affect each other. And that also has to be studied through computational fluid dynamics. If you have a very large industry whose investment is running into tens of thousands of crores, this cost of 1 crore of doing a computational fluid dynamics analysis is actually pittance for the safety of the entire campus. And this is what a competence that is very rare in the Indian civil engineering industry. It's used extensively in the aerospace industry, but not so much in the civil engineering industry. And time has come to build a competence in this direction in the country amongst those who are doing civil engineering work. The wake and the overpressure both can be quantified through analytical work, and then we can also do some measurements on the structure. So measurements on top of these structures, existing structures, is crucial for developing newer standards, and that is a pathway we have to take for cyclone resistance. When wind blows in one direction, interestingly, some of the flexible structures swing in the perpendicular direction, and this is called galloping. And this galloping is to be recognized in terms of additional effects of stresses that are induced in the structures. Well, of course, everyone knows about the flutter. When wind blows in one direction, in the same direction, there is an oscillation that is estimable and is done classically. But the transverse direction issue has to be brought in for design of normal structures also. In effect, when you see wind, as the structure becomes more slender and taller, the wind forces are larger. And so anytime you see any facility which is very slender and feeble in terms of light mass and flexibility, we are in great trouble. And so what are these items? First of all, you see all these projecting items are the ones that will be put to a greater level of effects. And secondly, the very light items like the sheeting that is used to clad buildings either on the side face or on the vertical, on the rooftop, both of them have the likelihood of being pulled off or pushed in depending on the level of forces. What is important to recognize is that the wind forces are 2 to 3 times larger than the gravity forces. That means this is a very severe loading, and this needs to be recognized in design and done very, very carefully. Whatever you design for the self-weight or gravity load, you have to design 3 times that in the horizontal direction for this wind effects in the extreme case. So this is something that it depends on the size of the structure, it depends on geometry of the structure, it depends on the flexibility of the structure. But notwithstanding that, the fact that this is serious has to be recognized. And I say this with emphasis because today we don't have a standard that really gives us deeper insights into all of this. While there is a standard for wind code, it is very, very introductory in nature, but doesn't talk about detailed industrial structures. So industries should now come together and form a standard that will be used for the design of structures to resist cyclonic conditions. Now, the wind effects have to be treated at 2 levels, one at the whole structure level as well as individual structural elements level. Individual elements because their pressure variations change depending on the position with respect to the wind direction. And that is where we see a large number of failure modes, which are either overturning or local crushing that we have, or lateral sliding and so on. These are all avoidable. And interestingly, countries like Australia and America have really developed detailed guidelines, especially for housing, they have done that, especially for buildings, they have done that. For industrial structures also, they have a number of guidelines, and we could take advantage of that to start with and eventually build our own specific country-specific documents. So uplifting, whenever you see that, you need to anchor them, and there are now commercial anchors available to hold structures down, whatever size, shape, and geometry of the structure you're talking about. Or you need to make the structure more robust, use reinforced concrete or heavier masses to anchor the structure. Sliding is a major issue, especially when the base dimension is very small and the structure is made of very light material and weak material. Suction is the biggest concern that we have in industry today, because the facade glass and the facade material that we come up with, we need to test it full scale under heavy pressure in real wind tunnels, and then only we should be able to qualify these materials for use along the coastal areas. Otherwise, we will see time and again these materials being pulled off either from the horizontal surfaces or from the roof surfaces, and it can cause a greater loss and threat to the life also in industrial environments. And this seeks a full-scale testing facility in the country for wind pressure. I'm saying this because we don't have enough wind tunnels in the country which do full-scale testing. Usually they are academic size, 1 meter and 2 meter sizes, but that's not what is sufficient here. We need much larger facilities, and we need to build, at least this nation deserves a couple of them, at least north, south, east, west, center, 5 of them at least it needs to make the structure safer. Now, having said that, what I talked about so far is actually called defiant design. That means whatever is the force, we'll design for it. But there's another strategy which is called compliant design, and that is the strategy of fuses. So we know of fuses in electrical circuits. Whenever the overcurrent happens, the fuse blows. Very good. So what we could do is, we have a building and then excessive pressure, wind pressure comes in and causes the roof to be lifted off. So instead of making the roof lift off, we can release that pressure off like the pressure cooker valve that we have. And so we can use a larger number of them if the structure is big, and diffuse all the pressure that is generated inside the uplift pressure on the roofs. And this will work both for normal functional use, which is exhausting the air under summer conditions, as well as protecting yourself in the winter. Also, vertical surfaces also are having such threats, so we need to provide vertical surfaces also to have such fuses which will dissipate that force out whenever it is required. What is learned over large amount of work is that inclined surfaces can be threatening, and they can cause very, very difficult flow of forces. So best is to see as close to horizontal as possible, and then that is manageable with the help of these air vents, automated vents that I talked about. Profiling of structures is also very crucial. Every time we make boxes, and all the boxes have sharp corners, and those sharp corners are not the best friends with wind. And so those sharp corners have to be rounded off. And this is classically talked about in a guideline that we can prepare for cyclone resistant structures. Another strategy that is seen today is that instead of making the structure as a bluff body, blunt, standing against the wind, we can allow the wind to flow through at intermediate levels and thereby reduce the force significantly. A large factor we can drop the force on the structure. So the geometry of the structure that we have plays a special role, not only in the wind effects, but also there's a huge noise. When wind blows at 250 kilometers per hour, 300 kilometers per hour, there's a noise that is created, and that can be avoided by careful design of the geometry of the structure and dissipating away the forces of the wind flows that are there around the structures. Let me talk about effects of mitigating the issues of water. Water, all of us know that it's a lifeline for us, and so we go and build everything close to water. Very good. But what then happens is we need to do this site selection carefully for our industries. Problems of waterlogging in low-lying areas cannot be solved by structural design. It cannot be solved. Like it was said that the buildings, tall buildings cannot be designed for collision with aircrafts. Same story. When cyclonic conditions come and you have a structure on that, we can design for that. But when it comes to low-lying areas and floods, it's not a structural solution. It is a site selection issue. And this has to be done very carefully. Now, there's a contrasting issue. Somebody can even propose that, oh, when there is Water logging, I can put it on stilts. Well, if you have earthquakes and cyclones both happening together, like let us say in Orissa, then you can have stilt as a problem for earthquake, and stilt may give you this relief from water point of view, but it can also cause uplift forces to increase on these tilted structures. So we have to be very careful when we blindly choose one hazard and design the structure for that hazard or prepare the structure for that. Source is the main issue. You have to tap the water, prevent the water from entering. Once it enters, it will become a headache for us. So water logging in terms of ponding, this stagnation should be avoided through proper sloping, and you need to have the drainage happening because by the designed roofing slopes. But what is also done is that there's a large number of basements being used in industries, which we should avoid significantly, especially in cyclone prone areas, because water will enter into the basements and that can cause huge embarrassments. While we will continue to protect our foundations from moisture entrance, every engineering material will eventually give up on water. Water is such a fundamental item, it will pass through every civil engineering material that we have in nature. And so we have to be very careful to say that we are waterproof. No, we are not waterproof. We are water resistant up to a certain limit. After that, we are not. So best is to avoid basements, and any amount of money you want to spend in roof treatments has to be spent on sloping the roof and managing. Of course, we will also use some hydrophobic paints and then make sure that waters will slide away quickly in the direction of the slope. So that we will continue to do. But what is clear is if you have a poor drainage, then you will have to do the cover up job more frequently, which means that it is recurring cost, huge recurring cost. I will quickly touch on refuge shelters. Refuge shelters have to be built on the coastline and they have to be on elevated ground, especially where there is flooding. But the key point that has to be reflected here is if some people get locked up for 2 days, the sewage system has to work, and which means the septic tanks also have to be elevated in this area. And this is one point that I request should be embedded in the new refuge shelters that are built along the coastline. If there are areas where flooding won't happen, you can keep the septic tank at a lower area, not a problem. But if you are looking at waterlogging, we have no choice. Finally, I'll close by talking about risk assessment. First of all, we need to reassess the wind map of India because the numbers are exceeding in local sense from different events. So we need to re-examine this whole subject because we've done it many years ago. Second is that the wind pressure monotonic versus dynamic flutter is something that we need to reflect in the design process a little more formally. We need to have a design philosophy for each industry has to set what is the design philosophy of theirs for the different facilities that they have on the campus. They have to tag them red, orange, yellow and green and give us a design philosophy for each of them where they want to place each of these facilities. Once that is done, the design process will then have to be tuned to meet that design expectation. And this is the process of development of standards that we need to do for the industry specifically. While in earthquakes, we allow damage, in cyclone conditions, we don't allow damage. And so we have to design for the full force. So you can't make a mistake in the estimation of the forces. And that is why I was seeking a revision in the wind map of India. Structural design as of now and the Indian standards, we have one document which is guidelines for improving cyclone resistance of low-rise houses and other small buildings and structures. This is not sufficient for design of industrial structures. And merely having a wind force loading standard IS 875 Part 5 is not sufficient again for us. Part 3 is not sufficient for us. And that is why I'm seeking that we need a detailing code, a design code for the various structures, depending on their geometry and their adjoining structures, how to treat them. While you can leave all of it to the engineers, but the engineering competence has to be built by giving them formal guidelines. So we need actually to build competence in the engineers, give them a closed loop method so that they know what they're designing and what they're giving to the client. And that is what we have to head towards, which means the wind structural engineering requires a greater attention from now on if you want to protect structures from cyclones. While wind science also has to grow, we need to capture what is the wind effects on these structures. The bylaws will have to now start looking at some of them very carefully currently some of the items that are permitted may have to be dropped, and we may have to insist compulsorily a few more items in a certain coastal area which is prone to cyclone conditions. So again, cyclone risk assessment can be done at 4 levels: qualitative 2 levels and quantitative 2 levels. And I think the industry should begin at the quantitative level 3, simple quantitative, and it is possible to do quick calculations and identify which of your structures are under risk at this point of time. While we will over time build all the 4 documents, so that the document number 1 will go into bylaws, number 2 will go into design standards, 3 will become the assessment for the industries, and 4 will become the R&D effort for specialized structures. And so we require all 4 of them. Indian industry should come forward and build such a system. And this is where, depending on the category that you would place your structure in, for the severity of the losses, you will have to then put your design standards also tuned accordingly. And so the levels of risk that you will be putting your structure into is known to you when you're running an industry. And so whether you like that risk or you don't like that risk, this is what you have to define as the client owner of the structure of the industry. You need to figure that out. I'll stop here by adding a few thoughts, saying that wind demand has to be understood more carefully and more accurately, and wind capacity has to be understood more accurately. In the designer side, we need to give more support to them in time ahead. We are using a large number of untested and unregulated technologies in the industry just because it is available internationally. It is not proper for a nation of our size to have structures built without a national standard on it. While it is true that we have to encourage new technologies, we should also see a pathway for a fast tracking of the new technologies by full-scale testing and development of standards. No care can be less when we say we want safety in the structure. So pre-engineered buildings will be one of those items that will be worrying me when industries are being discussed from cyclone point of view. So 5 suggestions or 6 suggestions from my side. Site selection has to be very careful. Multi-hazard design is compulsory for us. Providing fuses for wind effects at predetermined locations wherever it is permissible. If not, we have to use those wind exits. And then draining of water on all sides. And then 5, in a model industry cyclone risk mitigation program is what I'm seeking today, because the guidelines came in 2008, and industries need to get a little formal from now on to make sure that there is a camaraderie and that the lessons learned by the bigger industries can be shared with the smaller industries, and thereby there is a sort of a mutual growth of each other. And the national guidelines came in 2008. In Chapter 7, it says we need to do risk assessment through vulnerability analysis, hazard zoning, and mapping, and then generate data and put it on GIS tools so that everybody can get comfortable understanding the impacts and do capacity development. And no better way to start than from the industry, because whatever national cyclone risk mitigation project was focusing largely on what the government should do, and it has done excellent work. But now the industry has to come forward and do its bit and follow Chapter 7 of the guidelines and implement that urgently. And wind speeds, I talked about that. Cyclone risk mitigation projects, we can start with pilots, and 3 industries can come forward, small, medium, and large, and we can implement the mitigation measures and share them and with others, document them and share them with others over time. But what I'm seeing is that if we should start with smaller structures, build confidence, and then do larger structures, that will be the way we want to do. And last item, it hurts to see that competent engineers are dwindling by the day for many reasons, and many national level reasons. And that is why I'm saying a special effort has to be put in to train engineers who are working in the industry, who are just degree holders, but they have to be made competent. They're qualified, but they have to be made competent now. And that is the reason why we require a more tighter regulation and enforcement environment in this country, so that we can do good quality control in original construction, and somebody can do nice quality assurance by overseeing that construction, and eventually feed it back to build better engineers in time ahead. So it's time for action and not for just being a spectator on the galleries. Ladies and gentlemen, I will stop here by thanking NDMA, NIDM, FICI, and the Prime Minister's Office, Economic Affairs Office. In particular, I would like to say my regards to Rubab Sood, who brought me here, and Mainak Majumdar, who made sure that I'm sitting and speaking to you today. Ladies and gentlemen, thank you for your time and attention.
Thank you so very much, Dr. CVR Murthy. It's always, it's a learning experience. Every time we go through your presentation, I think from a Cyclone perspective, I think there are certain, from a structural engineering point of view, you mentioned certain aspects which needs to be undertaken in any sort of planning. It could be from a resilient infrastructure point of view. There are certain commonalities, whether it's cyclone or earthquake or floods or anything for that matter. And I think those points are very well taken. And I think we'll, as I said, it's a great learning experience listening to you every time. And I'm sure there are over 450 participants from not only India but from the region as well. We have participants from Thailand, Bangladesh, and Sri Lanka also. I'm sure they must be getting benefited out of what they are listening to from the experts. Thank you. Quickly on to the next and the last presentation of the session. I would now request Mr. Sharad Tripathi, who is the Chief Executive Officer, CEO of Fluidin, a Transoft Group company. Mr. Tripathi, as you know, we are running behind schedule, so I would request you to kindly squeeze your presentation to as much as you can, and but obviously share the essence truly with the audience which is present. Over to you, Mr. Tripathi.
Thank you, sir. I will try to limit myself shortly as quickly as possible. In fact, Dr. CVR Murthy has covered quite a few interesting subjects, and that takes out at least prepares the context of what I would like to go into. What I would like to point out also is that I'm sitting here in Paris, and every time I go to India, I'm horrified by the design of the airport terminals and various buildings, which are totally a closed box. And as Dr. Ghosh has pointed out, that especially in the tropical conditions like India, the buildings shouldn't be designed as closed boxes. There needs to be a better fit for the local conditions, and which is somehow missing there. So let me move on. The domain model, I'll emphasize and I'll look into the modeling aspects only. When we look from cyclonic point of view, it is not just one thing, it is multiple things. It is wind, it is flooding, it is the objects which are flying around. It could be the subsequent fire. So it is just not disaster management from one point of view. It has got to be from multiple issues together. As far as water ingress is concerned, I think that is quite easily manageable now. There is enough technology and enough resources available, and especially things like what happened in Kerala or in other places is easily manageable. I don't think really it's a big issue, and somehow we should get on to do that on a regular basis. So where I would like to take you to, let's see if I'm getting this. Okay. All right. Yeah, where I would like to take you to the specific buildings, and especially the subject about the, I think Mr. Pradhan was talking about how the business can be made resilient. It is not the large infrastructure only, it is also the small and large business like hospitals, like airports, like various industries. And there, of course, as Dr. Murthy had pointed out, a very important thing is to look at the effect of the wind. In France here, where I'm sitting here, we have some atmospheric boundary layer wind tunnels, And but unfortunately, not everyone can go to those wind farms. Especially look at the flexible structures. The cost is rather quite huge. Lately, I had asked IIT Kanpur, which is my alma mater also, for one single situation, it was something like 50-60 lakhs. I'm not really sure that many industries can afford to spend that kind of money. So I would still emphasize very much on CFD, through dynamics modeling, which is very much accessible and feasible now for large and small structures altogether. Technology is available to build over large 50-60 kilometer square kilometer area and more. 100 square kilometer is very common. And still look at the details of the buildings. So as wind flow in general, it is essentially means permeability, not the wind which is flowing around only. Flexibility is one thing, but also as the Dr. Chandran Ghosh was pointing out, we need to look at the ventilation. And ventilation is a very critical thing. And somehow I feel that the cost factor, which was coming into the picture again and again, that whether everyone can afford it, if we see it through the energy management as well as the regular ventilation, I feel that the same model can be used for cyclonic effects also. It will be much more palatable if we tell an industry that they can do energy saving by having a proper modeling where the internal and external flows both. And of course, I mean, situations like COVID, like here in France, we are all locked down because it is found that 95% of the transmission is because of the ventilation. In India, it has gone down because right now everyone can walk out and stay outside. But I'm afraid as soon as the air conditioning and the fans and the ACs will start, the transmission will also increase. So somewhere the cost of cyclonic resilience can be associated with the energy and ventilation of the buildings, and that might be more acceptable to the business. Now here I'll take one or two cases and just try to find out what can be done easily without really, and only based on CFD modeling. Here is one large airport building. It is Reunion Island, tropical conditions, which is very different what you will find in Europe usually. It's very open and it has got multiple scope structures, primarily to take care of the tropical stormy conditions, but also we have significantly the internal ingress of the air going into the building, and that is where the whole effort has to be. While the external airflow and in fact the flexibility of the structure by using fluid structure interaction modeling can be done rather without much without great expenses. What is much more important is to identify where the wind ingress into the building and the resilience of the critical equipment through those periods. And that is where I would say a detailed modeling becomes very important, but fortunately that also can be associated with the ventilation itself, and the cost factor can be brought down because it is the same model which can be used for low natural convection and heating or cooling of the internal space, which can be also used for the resilience of the equipment inside. The one other factor which also we found is very common in such situations is the subsequent fire, which we can also go into. Usually in such things, important thing is that we should avoid the toxic or flammable leaks, and if there is a leak, how far it might go, especially the tanks and the containment areas. So one thing which has come out when we modeled the Fukushima, we worked very substantially in nuclear buildings. We worked on Fukushima also. Is that we should forget about the modeling only the most damaging scenario, because it is very difficult, and that means essentially very huge cost of tying everything down and practically stopping the whole activity. We really should look into the failure of minor initial equipment, small equipment, and which may lead to some major hazard, which might subsequently follow up, because it's a kind of secondary effect, a domino effect, and so every instead of just modeling one single scenario, we should model multiple 5, 10 scenarios and see what happens if they may lead to something which could be very significant. Why it is important? It is, for example, about the dimensioning of the grills, ventilation grills. This is what initiated the process of accident in Fukushima. In the diesel generator room, the dimensioning grills were, for maintenance reasons, were stopped. They were not functioning, and because of that, the secondary power requirements were not functioning properly, and the secondary support system did not function, and the coolant fell down, and when the coolant fell down, the steam generators fell down, and the fuel elements heated up, and then it led to the hydrogen explosion and the reactor buildings coming down. So it was 3, 4, 5 steps further down the line, but it started by simple dimensioning grills, which is not a big deal. Anyone could have maintained that, but on that specific day for maintenance purposes, they were not functioning. Now, this kind of situation can occur anywhere. So I'll just take this specific case because for everywhere we need secondary generators, we need support situations. We know that there will be a power failure and we have to keep the building functioning. So very commonly we find generator buildings, and in generator buildings we have this issue that there are multiple entries. We do have to keep ventilating because it is generating toxic fumes. We do have fuel storage also. We have control room also. So quite a few critical things are there. And for the functioning of the whole building or the business, it is important that at least these last resort secondary support systems should keep functioning whatever happens. So this is where I just show the kind of modeling which is done. It is that we explored these 3, 4 items, that diesel hole and the bridge which takes the diesel conduits to the battery storage also, and then the fuel storage for the which might lead, sorry, it is written in French, but it means fire, and the local control. So there are warehouses, there are fire containment areas, there are firewalls, the technical control room, batteries. These are multiple critical equipment which have to be saved, but at the same time they have to be exposed to the external conditions, because without ventilation they will not function. And if there is a wind of something like 80 meters per second, as Dr. Moki was saying, about 220 kilometers an hour, then we are in trouble if at all anything fails and these equipments suffer a failure. So, for example, here we went into the modeling of each equipment, structural modeling as well as CFD modeling. Structural modeling for the local resilience, CFD modeling for making some estimation of the pressure and the velocity which may be encountered inside and outside. So this could be done very, I think, without great effort, and the cost wise also, it is not really, we are not looking at anything more than say 10-20 lakhs at best. If we can ensure that these critical equipment where we are looking for example, here we are looking at a Cyclone F4, 84 meters per second, 300 kilometers an hour, and the resilience outside, which gives me the velocity which is coming in, and the pressures which could be generated at the entry levels, the entries and the exits. We can see that the pressure variations could be of the order of about 2 to 3 kilopascals easily. And the velocity in and out could be easily, I should say, 100 kilometers an hour, which is rather quite substantial inside these buildings. And what is much more important, that in a cyclonic condition, the pressure is not only positive; it could be negative also. So, for example, what we do in ourselves usually, that we study in 2 wind directions and 2 different velocities, usually sufficiently high velocity, but at least 2 different wind directions, hitting the critical, hitting the large building, and see what is the local wind flow going in and out. So if we try to compare, we see that in the same room, in the same area, the technical control room, the pressure could be 1.5 kilo and negative 0.642 kilo. So something like 2 kilopascals of pressure variation. That means also that the structure will suffer that kind of vortex-induced vibrations. And as Dr. Murthy was saying on the building side, the same kind of galloping effect can break the fuel lines, it can break multiple things. So besides the velocity itself, which is about 43 meter per second, the pressure variation, which is going from 1.5 kilo to minus 642 kilo, will have to be survived. Same thing happens in other buildings also. We can see that easily it is going to about 3 kilopascals of variations, and the wind velocity of the order of about 20 meters per second. So I will close at that because I feel that modeling can bring substantial amount of cost cutting, and probably it can be borne out by the, I'll repeat again, by the ventilation and the energy saving, and which will be probably much more easily acceptable by any industry which is looking for operational, cutting the operational cost, which is energy cost. Thank you very much.
Thank you so much, Mr. Tripathi, for your detailed presentation and sharing the concept, what you've been practicing. I think it was very interesting, and I think very useful to our listeners as well. Moving on quickly, I would now request, so I would like to thank all the three eminent speakers and request Mr. Mansingh, the chair of the session, to please forward his concluding remarks, and we get on to the next session. Over to you, Mr. Mansingh.
Well, I must thank all the panelists, starting with Professor Chandan Ghosh, Professor Murthy, and Mr. Tripathi for excellent presentations. At least I got my appreciation of the issues involved and the steps to be taken. Particularly, I like I've just mentioned that Professor Ghosh, that is his pet theme, because I have been hearing him quite this thing, and his natural protection. You see, that is something you have to do, particularly even to mitigate the impact of the cyclone. Mangrove forests, the coastal plantations, and on that some very basic points were made. And I'm sure the forest department, the state government agencies, and the industry themselves, because this is now one of the conditions of environment clearance which is given. And so if that is done, I'm sure that the impact of cyclones would significantly come down. Professor Murthy made some very significant points about design preparedness and the standardization of the designs, where there are huge gaps in India, as he very rightly pointed out. And I'm sure BIS, which was taking the lead in this regard, they are onto it, and some improvements we can see in the in future. Professor Tripathi gave also, you are very right. That point was also made. Because the Odisha is one of the hotspots of cyclone, and in Hudud, first thing, within probably half an hour of that cyclone starting, the Bhubaneswar airport was gone. It means that entire roof blew off, etc. So obviously, our design and implementation of designs leave a lot to be desired, particularly for lifeline buildings like the airport, etc. It's another thing that the airport authority and the Bhubaneswar airport authorities, together with the help of the state governments, they got back the airport into operation within less than 24 hours. So that is what Then the chairman of the airport authority, they had given a He had given a presentation, excellent presentation. I thank all the speakers, and we certainly, all the participants would have gained from all the three presentations. Thank you. Thank you. Urva, please take over.
Thank you so very much, Chair Mr. Mansingh, for chairing this important session. Thank you all the eminent three speakers. Thank you for your contribution. And thank you for sticking to time, although we are running late. I will take this opportunity now to formally welcome Shri Kamal Kishore, Honorable Member, National Disaster Management Authority. Thank you so much, Mr. Kishore, for joining us. And we are really sorry, apologies. Please accept our apologies for this delay in starting this all-important session where we have speakers from three key UN agencies, from UNDRR, UNIDO, and UNESCO. I would like to welcome three speakers as well. Mr. Animesh Kumar from UNDRR. Very good afternoon, Animesh. Thank you so much for joining. Mr. Ardito Kodijat from UNESCO. Thank you so much for joining, Ardito. And Devajit Das. Yes, so finally we meet online. Thank you. Thank you for joining, Devajit. Mr. Kishore, before I hand over to you to chair this important session and for your remarks, I must also compliment the background you have. I think it's a very pleasing background with that beautiful painting right behind you. Ladies and gentlemen, as we get on to the last session of this day, which is on developing sustainable tools for reducing extreme weather events in the region. And I would like to give a brief introduction, although he needs no introduction, Shri Kamal Kishore, but a few lines on him. He's worked on DRR and recovery issues for over 22 long years at the national, local, regional, and global levels. Prior to joining NDMA, he's worked with UNDP for 13 years in New Delhi, Geneva, and New York. At UNDP headquarters, he led global advocacy campaigns to address disaster risk reduction concerns in UN's Sustainable Development Goals and the post-2015 Development Agenda. As program advisor, he has also led the development of disaster and climate risk management related elements of the UNDP strategic plan. This was since he's into his second term as the member of National Disaster Management Authority, and it's my proud privilege to welcome you again, Mr. Kishore. Over to you, and thank you so much for accepting our invitation to chair. Over to you, sir.
Thank you very much, Rubab, and I'm very thankful to Vicky for inviting me to participate in this session and work with colleagues. Animesh, I've worked with for many years now, and the others as well have interacted from time to time. So it's a very important topic, developing sustainable tools for managing the impacts of extreme weather events. As you know, 90% of disasters occur are somehow or the other related to weather and climate. Extreme weather events, extreme climate event account for 90% of disasters. In the last decade or so, we have made big progress in reducing the impact of many different types of extreme weather events. We often cite the progress that countries like India and Bangladesh have made in reducing mortality from cyclones. We also have, in recent years, seen progress in reducing mortality from heat waves. Of course, for the mortality from flood in most parts of the world has remained more or less flat for decades now. So I think that's the next frontier. And in addition to that, even for cyclone and heat wave and the others, going beyond reducing the impact on lives, we really need to look at reducing the impact on livelihoods. So, last year or 2019 Cyclone Fani, for example, the mortality was much lower than it used to be 10 or 12 years ago, but the losses in infrastructure sectors, other social sectors, enormous, something to the tune of $5 billion, 40% of those losses in power sector alone. So we really have to go beyond saving lives to saving livelihoods, and in that context, working on making our infrastructure systems more resilient to extreme weather events is really key. Mention has earlier been made of the Coalition for Disaster Resilient Infrastructure, which is an initiative we are working with a number of countries alongside UNDRR, represented here by Animesh. So I'm really looking forward to what colleagues from these three agencies, different agencies, UNDRR focusing the sort of the agency that has the stewardship of the disaster risk reduction agenda, UNESCO, the scientific agency looks at oceans, looks at the tsunami early warning system, looks at scientific development in this area, and UNIDO with the industrial development work, very relevant to the theme that we are discussing today. So I'm very, very excited to hear what they have to say and learn from them during this interaction. With that, let me turn over to Animesh. Animesh, the floor is yours.
Many thanks, Kamal. Very nice to see you and also be among familiar faces on the panel as well. Can we have the presentation that I had shared earlier? So while it's being uploaded, let me wish from here in Bangkok, everyone, a very good afternoon. And I would like to definitely thank the organizers in considering this very topical issue for discussion at the eConclave. FICCI in particular has been a long-standing partner of UNDRR and leads our private sector engagement and initiative, the ARISE network in India. So my name is Animesh Kumar, and I'm the acting head of the UNDRR Asia Pacific office, but my day job is the deputy head of the regional office. So in my presentation, I would seek to provide a global and regional overview on the key mechanisms and tools to address extreme events. So I would not go into the technology side of things, but focus more on sustainability and approach the topic from the perspective of physical risk, economic risk, and social risk, with a layer of resilience. And I'm sure my dear friend Pak Ardito from UNESCO and the colleague from UNIDO, Debajit, will delve deeper into some of the broader points that I would make. So next slide, please. So nearly 1/3 of the world's population is what we compose of in Asia Pacific, and with few of the fastest growing economies, and with multiple countries with rapidly expanding mid-income and middle class populations. At the same time, we compose of 45% of disasters, 70% of mortality, and almost 90% of the affected population. So while Asia Pacific continues to be the most disaster-prone region globally, as Kamal pointed out, the good news is that not only in India, but at least at the regional level as well, the frequency and impact in terms of mortality, what we call as the human impact, is declining or plateauing, especially in the last 10 years. And this is further corroborated by the global figures. If you look at the graph, we have recently submitted the Sendai Framework Implementation Report to the Secretary General, and there has been a perceptible decline, as noted in the report, in proportion of people died or affected due to disasters. However, this is coupled with an increase in economic and infrastructure losses. Next slide, please. So this graph shows the COVID-infected population in Asia Pacific in green, and just to give a kind of the message in terms of the duality that we are facing as of now in disaster occurrence. So the green graph is what COVID-infected population has been and in Asia Pacific, and the blue is the affected population by other disasters. So it's clear that while struggling against the pandemic, the Asia Pacific communities have also faced a series of other disasters, some of which have been having devastating, especially those resulting from cyclones and floods, impact. In 2020, on an average, hence, the region has faced 10 disasters per month, 85 deaths per week, and 150,000 affected per day because of non-COVID related disasters. So let us look at some of the overarching challenges that the region is facing. Next slide, please. So at the outset, Asia Pacific is not on the right track to achieve the SDGs by 2030. That's the overarching message. Within these, there are a few SDGs where we are really struggling. And the bad news is for us, at least from the DRR community, is that the disaster-related targets figure among such SDGs. The region is struggling the most on climate action and reducing the human and economic costs of disasters. Next slide, please. It is well known that the risk occurrence in the region is not uniform. However, the risk space across the region is increasingly overlapping with multiple dualities. On the one hand, we have vulnerable countries like the 12 least developed countries or 15 SIDS, And on the other hand, we have around 400 million people living in extreme poverty. These nations and communities are the most vulnerable to disasters. Similarly, on the one hand, we have several of the LDCs who will soon graduate to become mid-income countries. And on the other, around 800 million people, not extremely poor, but still surviving on less than $3.2 a day. The disasters pose severe challenge to such nations and communities who may be pushed back to lower development levels and extreme poverty as they strive to move up. And all of this gets complicated when they are exposed to hazards of all kinds, especially in the hotspots. Because it is these overlapping layers of hazards and vulnerabilities that pose grave risks to nations and communities. Next slide, please. So we know that hazards and hazardous events are dynamic. However, we often tend to perceive vulnerability as static. Vulnerability but differs over space, time, and context, and hence is equally dynamic. It's defined by physical, social, and economic and environmental multiple dimensions, and shaped by factors like inequality and exclusion. Next slide, please. Risk, hence, as we know by now, is systemic. It doesn't operate in isolated corridors, but in a jigsaw puzzle where each block has an implication on the other, as we are seeing in the context of COVID, together with series of other disasters. Unfortunately, our planning processes, next slide, please. Our planning processes for the future are based on an analysis of what we have seen so far. But climate change is rapidly altering the risk landscape, and the past is no longer the mirror of the future. For instance, the concept note for this conclave mentions 84 coastal districts in India, which are affected by cyclones. However, I came across a recent report from CEEW, where in the last decade alone, there are 258 districts which have been affected because of cyclones in India. So the challenge outlined so far points to the fact that if we want to operate in a dynamic risk environment, our planning processes has to be dynamic. So what does this mean for the addressing of extreme events in the region? Next slide, please. So the first step is to get over our cognitive bias and ensure that while we strengthen our disaster response capabilities, we also ensure that we address the underlying risk drivers. The key risk drivers like rapid urbanization, climate change, environmental degradation, weak infrastructure, etc., that exacerbate or sometimes result in a disaster. Further, we also need to move this forward from drivers of risk and identify what are the drivers of resilience. And within these drivers of resilience, we need to identify those acupressure points that will trigger resilient development. Next slide, please. Integrated climate and disaster resilience is the need of the hour, hence. Global efforts are being made to ensure we get away from a siloed approach to climate and disaster domains and ensure we look at both from the same lens. And this includes applying the common risk analytics to both and ensure the planning processes are coherent. The disaster risk reduction can also be seen as a short to medium solution to long-term climate and developmental challenges to achieve the common objective of resilience. Next slide, please. So risk and uncertainty have become the new norm. It has become extremely important that we strengthen our risk analysis capabilities to eliminate as many unknowns as possible from our analysis. And to do so, a multidisciplinary approach is needed with constant dialogue with the people on the front line to have a constant and consistent stage of scenario building. There cannot be a one-stop model in a rapidly changing world. And such comprehensive risk analysis should then be able to inform early warning systems, for example. Again, as risks are interconnected, isolated early warning systems do not work. We need to have in place multi-hazard early warning systems that are based on a thorough analysis of risk. And such comprehensive early warnings should also be impact-based. That is, be able to trigger an action by those who receive the warning, whether in institutions or communities, which is an evolution from what the weather will be to what the weather will do. And the early component of early warning should not be lost sight of. Timeliness in warning is of essence. A key challenge we often face is the availability of financing when most needed. Early warnings should also be able to trigger financing that in turn is helpful in taking preemptive action or rapid response. Further, risk-informed approaches also have a huge interface with climate adaptation, as I pointed out earlier. Nature-based solutions should be applied in every aspect of infrastructure generation, including through a hybrid mix of green, blue, and gray infrastructure. And I would encourage you all to review a publication on this topic we have just launched this month, keeping the regional audience in mind, but also the larger issue of infrastructure resilience that Kamal was mentioning, and that has been galvanized around the CDRI, is the way to go in terms of a very practical demonstration of risk-informed development. Next slide, please. So I have so far highlighted the importance of risk analysis in preparedness for disasters. However, once we have the full understanding of risk and its quantum, we know how much of risk we can mitigate, how much of risk we can avoid, and how much we can transfer. And such risk management decisions should also need to be having a layered risk financing approach, where for each risk management decision, a specific financing approach can be followed. For instance, for high-frequency, low-impact events, a social risk management approach through regular budgetary means and livelihood-based approaches can be followed. While for high-impact events, contingency financing and market-based approaches like bonds and insurance can be resorted to. Next slide, please. This slide essentially captures what I have outlined so far. The only point I would highlight here is the importance of planning. We need to have pre-disaster contingency and recovery plans in place. We often lose a good amount of time in starting the planning process once a disaster is already in sight or has happened. Planning in advance of a disaster not only establishes the SOPs for action, but also pre-identifies the funding mechanisms and sources. And of course, these plans need to be regularly revisited with changing scenarios. Next slide, please. While financing disaster preparedness and response is straightforward, financing prevention of disaster and disaster risk requires a different set of approaches. So we keep cautioning about limited resources for disaster risk reduction. However, it is not always and often about more resources for DRR, but often about distribution of resources and budgetary allocations, especially when we talk about multi-sector approaches. For instance, we know that capital flows often follow a natural process, and we need to risk inform this flow. We also need to revisit our public financing mechanisms and seek to make a shift from a contingent liability-based approaches to social risk management approach that is based on a sector and livelihood-based programs. The role of the private sector assumes very high significance, considering that they constitute over 70% of the total GDP in most countries. If the business and industry make losses, the country cannot prosper. The discussion on the role of the private sector in DRR hence needs to move on from a corporate social responsibility-based approach to their own responsibility to save their own losses using the DRR approaches, which I think is the biggest business case for DRR. Next slide, please. And all of these paradigmatic shifts that I'm talking about require us to revisit who is our target audience. A key shift we have to make is to move beyond preaching to the converts. We need to communicate better with the planning and finance ministries, central bankers, trade representatives, the real estate developers, for them to appreciate the value of risk management. If you're really serious about strengthening resilience and disaster risk management, more needs to happen outside the conventional disaster management domain rather than inside it. Next slide, please. And finally, and that's my last slide, it's all about we, the people. Communities should be at the heart of everything we do. Disasters don't discriminate, but the underlying vulnerabilities result in differential impact of disasters. I mentioned about early warning systems at the outset. A key feature of such systems is that they should be end-to-end and increasingly bridge that last mile where the communities most at risk live and often make a difference between life and death. Digital solutions and connectivity provide new avenues to attain universal assistance and outreach, and hence minimize exclusion errors. Data disaggregation, especially by age, sex, and disability, is a key requisite to inform risk management efforts. We cannot manage what we cannot measure. A word on informality in our economies. In several countries in Asia Pacific, over 90% of the private sector are MSMEs and often operate in the informal sector. And for the informal sector, risk-poverty nexus is a very strong nexus due to limited assets and savings. And to address many of these challenges, social protection programs need to be strengthened. The safety net programs not only help reduce vulnerabilities, but also become the carrier of relief and assistance when needed, as we saw during the COVID-19 response and recovery efforts. So final slide, next slide. So before I conclude, with all these words, I'm very pleased to invite in advance to all of you to upcoming Asia Pacific Ministerial Conference on Disaster Risk Reduction, where the issues that we have discussed today so far will all be highlighted. The dates are yet to be announced, but it will be a virtual event somewhere in the middle of the year, hosted by the Government of Australia. With these words, thank you very much for your attention. I look forward to the discussion. Thank you.
Thank you very much, Animesh, for that very comprehensive and very multidimensional overview of the issues in the Asia Pacific. I particularly noted your reminder that while we've made a lot of progress in the last 10 years, in many ways that progress is precarious. Disaster risk reduction is not a niche agenda, but it is really fundamental to sustainable development of our people in the region, of the well-being of the people of Asia Pacific. With that, now let's turn to Mr. Aradito, Pa Aradito from UNESCO.
Thank you very much. Thank you very much to Kamal for the introductions, and greetings to all. Also greetings to Animesh. Very nice to see you again. I think we haven't seen this year, so good to see you. Also, thank you very much for the invitation. Although when I was invited to give a talk on this event, I already mentioned that my portfolio is more on tsunami, not on the hydrometeorological hazards. So I'm not too sure if I can contribute to the event. But then upon discussions, there might be something that I can share. Considering what is we have learned from what happens in Odisha when we are working on the tsunami ready community. So I'm not sure if I can share, just to try. Did you see my screen?
Yes, we can.
So thank you very much. So I'm trying to look into the how actually when we work in establishing a tsunami ready community, we are actually capitalizing on cyclone preparedness that has been built in Odisha, and this is something that I would like to share with you, as considering especially Odisha is one of the community that has been recognized in Indian Ocean. So just briefly, this is about IOTIC. So I'm basically in UNESCO IOC, and I'm responsible in the tsunami Indian Ocean Tsunami Information Center, which basically focusing on building preparedness for effective emergency response, as well as tsunami early warning systems, focusing in the Indian Ocean. This is some of the activities that we have achieved within the from 2017 to 2020. We work with 25 Indian Ocean member states. We work with 3 tsunami service providers in the Indian Ocean, which is India, Indonesia, and Australia. And we have conducted a number of activities, capacity buildings, workshops, lectures, and so forth. And in 2020, we actually achieved in recognizing 2 of the Indian community as Indian Tsunami Ready community being recognized by UNESCO IOC. We also involved in numbers of projects, as well as conducting the exercise in the Indian Ocean. Before I move a little bit further about this, I just would like to inform that starting 2021 until 2030, we are actually come into what we call the UN Decade for Ocean Science for Sustainable Development. And this is basically into defining on the ocean that we need for the future that we want. And there are actually 7 outcomes as the ocean decade. One is to have a clean ocean, to have a productive ocean, and predictive oceans, safe ocean, accessible ocean, and inspiring and engaging oceans. And most of our activities in Indian Ocean Tsunami Information Centers basically relates to these predicted oceans and safe ocean. when we talk about safe ocean, we are talking about an oceans which does not have. It is not that an ocean that does not have any coastal hazard. Coastal hazard will happen, as that's basically the nature. But what we call the safe ocean is that basically an oceans that is understood. And when we talk about understood, then there is a need to actually understood in terms of what is the topography of the coastal as well as the bathymetry in the oceans. And for that, we can then make a predictions in terms of, for example, inundated areas due to tsunami and so forth. Second is basically oceans that is observed. So there has to be a number of monitoring systems that can actually observe the changes in the phenomena in the ocean. The last is, of course, oceans that can be predicted, in which that then, based on these observations, based on the understanding of the oceans, then we can predict if there are any upcoming threat to the coastal areas. So that relates what we call by the predicted oceans. In terms of safe ocean, what we are talking about is that people can actually continue to interact with the oceans, with the sea, for their livelihood, for their lifestyle, without having fear of any coastal hazards. And how to do that is basically making sure that the community have a very good awareness about the coastal hazard, have a very good awareness about what the areas that they are in, have the knowledge, have the preparedness, have the skills, as well as the abilities to save themselves in case of an emergency. And this is where actually we try to build to achieve what we call the safe ocean. And by working on this, basically you are contributing to all the global frameworks. You are contributing to the SDG, of course. You are contributing to this Ocean Decade. You are contributing to the Sendai framework, of course, and you are also contributing to the and we can actually showcase this in the Tsunami World Tsunami Awareness Days. As I mentioned, because my portfolio is basically focusing on tsunami. So just to take into what we learned, I'm not going to go into details on this, but because I think you're much better than me about this, the great super cyclone in, especially in Odisha in 1999, where it has actually caused a lot of life loss as well as economical loss. But I think in this super cyclones becomes a game changers in, especially in Odisha, in which that based on what happens, the state government of Odisha started to actually build their own preparedness for cyclone. They built multi-purpose cyclone and flood shelters. They developed community preparedness. There is, in terms of construction technologies of houses, they are also starting to look into cyclone-resistant buildings. There is established disaster managements and disaster managers within the community. There is a very strong correlation as well as linkage as well as cooperations between central, state, district, blocks, and communities in terms of the disaster management plan. So the cyclone, super cyclone actually changed all of this and built the cyclone preparedness for, especially for the coastal communities in Odisha state. Now, based on that, as you know, India has INCOIS as the tsunami early war, the agency who is responsible in tsunami early warning system, and INCOIS has been working in all of the coastal of India and identified that even in 2004, it's basically only Nicobar, Andaman, which is really affected by the 2004 tsunamis, but the tsunami hazards in coastal areas, either on the eastern part as well as on the western part, is actually tsunami prone areas. And with that, then the state of Odisha starts to participate in UNESCO IOC's activities related to tsunami preparedness. So they are engaging in most of our tsunami Indian Ocean Wave exercises that we did 2011, 14, 16, 18, and 20. And gradually the capacity and capabilities in terms of emergency response related to cyclones were also adapted so that it can also be used as a response to tsunami emergency. Of course, and just to mention, there are now actually 2 communities in Odisha, in Noliasahi in Jagatsinghpur districts in Odisha and Venkatraipur in Ganjam districts, who actually already received the tsunami ready recognition from UNESCO IOC. This recognition is given for 3 years, and this is that there is a sustainability. There are reporting that needs to be done by the community that saying that they are fulfilling all the requirements and they are sustaining their level of preparedness according to the indicators that we have set. So there are mechanisms to make sure that when they receive the recognitions, then they have the obligations to actually maintain this level of preparedness throughout the as to be continuous being recognized. Once they actually miss all of this, then their recognitions can be taken out or can be revoked. So now, I think this recognition was given in July 2020. So they have within the next 3 years, we will monitor as well as evaluate their level of preparedness. So of course, we need to understand it's completely different between cyclone and tsunami. And there are, in terms of emergency response, responding to cyclone emergency as well as responding to tsunami emergency, it's completely different. And this is where actually the Odisha disaster management agencies at the district level, as well as the block level, as well as the state level, were able to actually adapt and modify their previous cyclone preparedness and making that it actually follows the requirements in terms of tsunami when there is an emergency. Tsunami is a fast-paced event. It can happen in minutes or hours. It depends on the near field or the far field of the case. But then the basics of the tsunami, the basic of the disaster preparedness is almost similar. The only quite specific is that the timeline that has been developed in terms of responding to a cyclone as well as responding to tsunami, it is different. In tsunami evacuations also might be different. There is an evaluation in terms of whether the multi-purpose shelters is actually located in a safe place looking into the tsunami. So there are a number of evaluations being taken to make sure that although we are capitalizing from the cyclones, but it still fulfill the requirements of the tsunami emergency preparedness. So the IOC Tsunami Ready is basically a program that we developed and it has been implemented since 2011 globally. Mostly it started in Caribbean and gradually it moved to Pacific and now it is being implemented in the Indian Ocean. And these are the reasons why we need the Tsunami Ready, because as you know, in many cases, tsunami early warning system, even though it works, but if the people doesn't know how to respond to this early warning system, then the warning systems fail. And also we know that in the community that is not prepared, there is a very higher risk in terms of loss of life as well as loss of property. In many cases, especially for example, taking Indonesia, it is we are really in the near field tsunami where the tsunami can arrive within minutes. Then the response of the community needs to be based on this natural phenomenon rather than waiting for official tsunami early warning system. Of course, there might be a broken warning chain because of the, especially for example, if there is an earthquake, communications broken down and so forth. So there are a lot of consideration why actually the community itself needs to be their preparedness in terms of responding to this tsunami. So it is we are focusing on community preparedness, but we are part of the end-to-end early warning system. So we link actually from the early warning systems that is doing the detections, the monitoring, and also lead it into the how actually community can be prepared. It is a performance based on a certain indicators agreed globally. At present, there are already 25 communities in 15 countries that receive UNESCO IOC recognition as a tsunami-ready community. And as I mentioned, mostly in Caribbean, then it's moved to Pacific, and in Indian Oceans, we only have, at present, only 2 communities that it has been recognized, which is in India. The program is basically building the ownerships of preparedness, bringing the ownership of the preparedness to the community. So there is a share of responsibilities between the official disaster management offices, either at the state, blocks, as well as sharing the responsibilities at the community level. Building these tsunami-ready communities, we are ensuring that we are following a certain process, which is it has to be structurally as well as a participatory approach, and it is a collective effort that needs to be involved a lot of stakeholders, basically to meet the guidelines and the indicators. We have 12 indicators consisting the component of mitigation, preparedness, and response. These are the 12 indicators that needs to be fulfilled by the community to be able to be recognized as tsunami ready. So there are certain checklists as well as measures that needs to be accomplished by the community to be recognized. And then based on these 12 indicators, this is something that they need to actually maintain to be able to continue to be recognized as a tsunami ready community. I'm not going to go into details of each of the indicators, but this is basically covering, again, mitigation, preparedness, and response. We really learned from India how actually it was implemented, because as I mentioned, in the oceans, India is the first country who received this UNESCO IOC recognitions, and the 2 villages are in Odisha, and we try to learn into what's happening. But and then the most important thing is number 3, which is there is already a lot of background works being done in India, and this is based on the cyclone preparedness. So there is already the disaster risk reduction policies, plans for cyclones that has been set up. There is already settings in terms of the provincial, district, block level of centers. There is a lot of buy-in from the community, how important it is because of their horrifying experience. So all of this actually becomes one of the success stories, as well as the background why it is quite India can actually quite fast in terms of implementing this tsunami ready. So number 5 is very important. So there is a strong ownerships on disaster risk activities in the villages. Again, this is because of their experience in 1999 super cyclone, and there is a strong provincial relationship between the Odisha state disaster management agencies until the community level. And then based on these 2 recognitions to the 2 community, state of Odisha is targeting 324 villages in Odisha will be receiving the tsunami recognition. So they are now working on this. They are planning to have this in 2022, but because of COVID, we just been informed by the OSDMA that it might be delayed because of this COVID, but they continue to work in terms of making sure that most of the villages in Odisha will also receive this tsunami ready recognition from UNESCO IOC. So that's maybe what I can share. Oh, and I think when we talk about tsunami ready community, one is to make sure that we understand that it is an ecosystem of the society. So it is not only the people, We are talking about tsunami ready. We are talking also about safe schools and safe hospitals, an initiative that has been implemented and initiated by UNDRR. We are talking about tsunami. And one thing that is actually still missing is on this side, which is we are talking about tsunami ready industries, tsunami ready airport, harbors, tsunami ready infrastructures, tsunami ready hotels, and so forth. So there are still a lot of works that we need to do to make sure that on this side there is also a built capacity in terms of tsunami ready. Thank you very much. I hope this is useful in sharing. Thank you.
Thank you, Paradito. That was a very interesting presentation. You started with an introduction to the decade of ocean science for sustainable development. So we are talking about the decade in the first month of the decade itself. So that's very good. I think we have to really make use of this opportunity to advance the disaster risk reduction agenda. The presentation you made about the Indian Ocean Tsunami Early Warning System, the work that has been done since 2004, after the 26th December 2004 tsunami, is truly an example of international collaboration in achieving risk reduction for people who are exposed to natural hazards such as tsunamis. It is also an example of how to take science to the people and not just remain in the ivory towers. The whole rigor that you're bringing about under UNESCO's leadership in terms of what really are the indicators of a tsunami-ready community. So, as much seriousness in doing rigorous work at the community level as doing high-end science in terms of detecting the tsunami occurrence and relaying information on that. So thank you for that. With that, now let's turn over to Mr. Debajit Das from UNEDO. Debajit, the floor is yours.
Thank you. Thank you, Kamal Kishorji, and good afternoon, all the audience. Can you hear me? Am I audible? Yes. So I did prepare a presentation, but maybe I'll just talk for the sake of saving some time. So what I wanted to talk is about industries, how they should approach towards preparing themselves to face the extreme event. And as an event agency, of course, we always correlate the extreme events with climate change. And whatever our industrial or day-to-day operations, I think that has a bearing with what we are creating. I think we all know that this 1 decade or 2 decades of extreme events has almost lost around 0.5 million human deaths and the loss of around 3.5 trillion. These are some of the figures which shows the severity of extreme events. And so at the backdrop of what is this climate changes are happening, the frequency, the intensity and spatial extent or duration or the pattern of weather, I think these are all science and different agencies are working as to understand the dynamics of it and how we can well prepare ourselves as a society on different parts of the world. So I think India, in terms of climate risk index, I think we have now jumped to more than 9 places in terms of our vulnerability rankings. And in the last, as per the German watch, I think our position is 5th in terms of the climate vulnerability country. So whether it is storms or cyclones, drought, or we are seeing a lot of different events in India, and which are causing catastrophic damages. And in doing all of this, I think industries are very much part of our society, and they are contributing as well as they are also responding to this severe events. Now, what I would highlight is only a few things about industries, how they should approach. There are, of course, the topic is about tools. There are different tools which have been made, but it depends on which sectors and which kind of cluster or parts of the world we belong to. So I'll put up a kind of generic approach as to how industries should prepare or kind of approach to mitigate the risk. I would just take one or two small minutes to apprise you that you need to, in India, has been working on a knowledge platform which is called Building Back Business from Crisis, keeping, of course, COVID in mind. In recent times, the impact which has been created and how industries are trying to cope up. So this repository of information has been greatly appreciated by the MSMEs around the country. And Ministry of MSME also is showing a lot of interest into this. So in a specific sections where we have built in this talks about various things like occupational health and safety is only one part, but then how the industries should protect their supply chain, how should they protect their operations, and how should they protect their manpower and health and safety. Overall, in each of these elements we have addressed, there's a detailed kind of a checklist has been prepared and few presentations, and there is guidance and fact sheets are incorporated, and practical advisory notes has been given by different experts in this knowledge platform. The platform's website address is b3cmsme.org, which could be a lot of use for different industrial partners who is probably participating in this. So in there we have highlighted both, like the outside the boundary of the industries, how it should be, disaster should be seen, and inside the industry, how you should have a plan to have a for mitigating the disaster. Now, then we have, of course, like in terms of tool also, World Bank also has kind of screening tools World Bank has prepared, which is known as World Bank Climate Change Knowledge Portal, and they have designed a specific tool called Think Hazard, which is a web-based tool enabling non-specialists to consider the impact of disasters on new developmental projects. So what I want to talk is how the industry should prepare. One is, of course, this is the full damming cycle, what we know as PDCA cycle, like plan, do, check, and act. That's how we basically improvise our system. So we need to identify what are the different risks involved with your industrial operations. So you need to consider, as per your location, what are the types of natural disaster your region is susceptible to. Then after doing that, I think determination of the critical functions, what are the different functions of your operations would be seem to be susceptible to such kind of disaster that needs to be identified. And accordingly, you need to also determine the disaster effect. In doing that, how extreme weather risk can either affect your critical operations, and overall as a business, how this can have an impact. That impact analysis needs to be assessed. While doing that, one important point is what we used to highlight is that it needs to be, you need to think of beyond your industrial boundary. When creating your emergency plan, you should not only focus on region, but also see where your key customers and suppliers and vendors are also located. So every time when you plan this kind of emergency plan, you need to have a backup plan, for addressing your stakeholders, the whole ecosystem you need to keep in mind. Then protecting the people who works for your industry or for a business, that's you need to the development of an emergency evacuation plan to get your employees out of the building safely, suppose some disaster happens, and stock up on safety tools such as whatever equipments you need to have during a flood or wind or any kind of adverse situations. Then utmost also important is you protecting your data, because apart from the people who operate it, I think one of the critical elements of all our industrial or business operations is our data. So we need to have the cloud storage of your whatever business data, critical data, that those need to be identified and kept in safe place. Suppose something happens, you have an option to retrieve it. The next step is to keep in touch with the people. Once the disaster happens, I think even at the time of disaster, how you should be readily able to outreach to those people whom you care for as in part of your business operations. So you need to have a list of employees, customers, and suppliers. Keep it handy or online and update it completely monthly. And then once all these things are in place, keep it going. You should keep the operations going. Once even the disaster happens, post disaster also, you should figure out where employees can work, or if suppose there is a severe weather conditions, whether they can work from home, whether they have the access to different equipment, software, network access. So a backup plan should be there, and accordingly your response should be decided when this disaster happens. Now there are different alternate approach also. People suggest them different organization, multinationals, big companies. They have also their different approaches. Some of them also suggest a very straightforward approach, like you need to assess your infrastructure as to what are the elements that are prone to the disaster. Keep the line of communication open. You should lead by your example. And as far as possible, the automation or your orchestration should be in place so that the operations is smooth whenever the disaster happen. And your emergency plan always needs to be tested and repeated so that it is robust and your fast response is ensured. So these are some of the approach. Now you need to, when we talk about as a part of UN agency, of course, we are responsible for the industrial development. And as we all know, there is 17 SDG goal, and one of the SDG goal is building resilient infrastructure and promote inclusive and sustainable infrastructure. So there we address climate resilient industries and infrastructure. So in doing that, what is important is from the design itself, when the are siting or in a specified place, like Dr. Murthy was addressing certain technological advancement or our tools which can be used to incorporate in the design itself. So those kind of approaches are required at the siting itself. Now once you have placed your industrial site, then I think there are very small limitations which may happen to facilitate the retrofit of certain elements. So nowadays, when we talk about siting an industrial zone, I think this our unit is one of the concept is very popular. That is eco-industrial park. Unity has demonstrated along with GIZ and World Bank a very robust design tool where all these different elements, like your in terms of environmental management, energy management, or water, or natural environment and climate resilience. So that is part taken care of as a environmental performance indicator in the eco-industrial park placement. So we adopt basically a value chain approach for implementing the building climate resilient industries and for different communities. So also the policymakers, we basically do some kind of advocacy so that it is increasingly recognized that the growing needs of integrating the strategies for climate resilient infrastructure along with the industries in mind into long-term development programs. We have demonstrated successful such kind of approaches of building the climate resilient infrastructure not only in India but also in different parts of the world. One successful story which I can just give an example is from the Pakistan Sialkot's tannery industries, which is flood prone, and there is a new design which has been established so that the industries become flood resilient.
Devajit, maybe if you can begin to wind up. Thank you.
I think I am just closing. Yeah. So with this, I think what is important for the industries to understand is their different stakeholders, how their participation is ensured in the whole disaster management plan process, and how their capacity is built up in terms of what they can do. Suppose a disaster can happen, that should be the responsibility of industries, and that's how probably the efficiency can be built up. With this, I think I'll wind up the discussion for this. Thank you so much for your listening.
Thank you, Mr. Devajit. That's a very interesting perspective. Particularly the work that you're doing on building back business from crisis and all the different elements of this. And also your reminder that when you're talking about building resilience, it's not just the resilience of the core operations, but you also have to look at your supply chains, your clients, your customer base. So really, what is very topical these days, a systems view of risk and taking a systemic approach to risk reduction. So, colleagues, we have had a very fruitful a session where we had three very different perspectives. Animesh gave an overview of disaster risk situation in the entire Asia Pacific. We heard from Aradito the progress that has been made in tsunami early warning system, particularly the work on rigorously pursuing community preparedness at the local level and having a very clear notion of what qualifies as a tsunami ready community. And then, of course, we heard an industry preparedness perspective from Devajit as well. With that, I would like to thank everyone for participating. If there are any questions, since we are running late, I'm sure Vicky and our hosts will facilitate interaction with the speakers. Thank you very much and have a very good afternoon. Stay safe.
Thank you so very much, Kamal Kishore. Thank you so much for chairing this very important session. Although we are really behind time, but what we propose is that there are certain questions which we'll send out to the speakers individually, and we'll connect and we'll seek those answers and we'll share it with the people who've asked those questions. We have almost over 400 participants who have signed in on our bike platform, which is a FICCI's property, a virtual platform which FICCI has created exclusively to facilitate such deliberations, which can have endless number of participants from across the world. So thank you so much again, all the three eminent speakers, the chair, Kamal Kishore, thank you so much. I would like to take this opportunity to also thank our partners, the GIS partner, ESRI India, ESRI India, associate sponsors, GAIL, Indian Oil Corporation Limited, Power Grid, and RMSI. Thank you so much. Yet again, this was a very intriguing session, as it was expected. We had some very key, eminent professionals from UNDRR, UNIDO, and UNESCO talking, and I think there have been very interesting, very rightly were pointed out by the chair. So we've taken a note of this, sir, and Kamalji, this 3-day program, which we have organized in partnership with NIDM, NDMA, and Economic Advisory Council to the Prime Minister and DST, we would be compiling the outcomes and the thoughts which have been shared by the experts during these 3 days, and we'll be submitting formally a report as an outcome report of this eConclave to NDMA and to all our partners. So on that note, till tomorrow, 11 o'clock, when we have the third technical session, which is on analyzing risk of cyclones in the. I think this is one of those subjects which even the CDRI is looking at very seriously. As when you talk about resilient infrastructure from power and telecom point of view, and that is one of the reasons, Kamalji, we've picked up this specific subject, where we have speakers from Adani Power, we have from Power Finance Corporation India, Griffith University Australia, an expert from there, and also Power Grid Corporation. So that starts tomorrow. So requesting all the participants to join us, sign in tomorrow at the same time using the same email ID which you used today to log in. Until then, thank you so much and have a good day ahead. Thank you. Thank you. Bye-bye.
Thank you very much. Thank you.
Thank you, Animesh. Thank you, Vito. Thank you, Devaji. Thank you so much, Kamalji. Thank you. Thank you, Dr. Ghosh. Thank you so much for all your support. Thank you, Mr. Tripathi, for your very interesting presentation. Dr. Rajkumar, thank you again, sir. Thank you so much for supporting us today. Thank you, the entire team from FICCI, Akhil Gupta, Mainak Majumdar, Sanjeev Kumar, Varun Sharma. You guys have been amazing. And also the team from NIDM, who's supporting Chandan Ghosh Saab. I think it was a very fruitful day today, and very interesting deliberations which took place. And I'm sure the participants who are connected with us must have really benefited out of this. So until tomorrow, I will take your leave, sir, and we will connect again tomorrow at 10:45 and for more interesting questions. Thank you so much. Bye-bye.
Okay.